Welcome back to section 5.5. I'm Gregory Carlson. Let's finish off this section with a few more examples. As you can see, this one is similar to the last one we did. I would recommend elimination because everything is lined up. Why don't you try to pause the video and see if you can get it on your own, and then see if my answer matches yours. Okay, hopefully you pause the video and have an answer, so let's see if you match me. I notice that the X and Y's are not lined up. So that's very bad. So hopefully you didn't just jump right in, because we need to make sure that things are lined up. So I'm going to leave the top equation alone. 3x squared plus 2y squared equals 39. And I'm going to swap the x and y terms in the second equation. So 9x squared plus 6y squared equals 117. Okay, so with that being said, the next thing I'm going to do is I noticed that if I multiply by -3, then I'm going to be able to cancel the x's. So let's multiply the top equation by -3, and that gives us the following: -9x squared minus 6y squared equals 39 times -3, which is going to be -117. And the bottom equation is 9x squared plus 6y squared equals 117. And you can probably detect that something strange is going to happen when we try to add these equations together. When we do, we get 0 plus 0 equals 0. And so 0 equals 0, and that is a statement that is always true. So that means the answer, the solution set, is all real numbers because it has an infinite number of solutions. And that's pretty much it. Now remember, if we had gotten something like 5 equals 0, then there'd be no solution. Now, one reason for why there's infinite solutions is if you went back to here and just multiplied the top equation by +2, the two equations would match. And so it makes sense that if it's a solution to one, it has to be a solution to the other, because they're basically the same equation if you just multiply by a constant. So, as a reminder, this system would be dependent and it would be consistent. So make sure you still remember those vocabulary terms: independent versus dependent, and consistent versus inconsistent. Let's solve this next one. Find two numbers whose sum is 86 and whose product is 1593. Well, if we have two numbers and their sum is 86, that means x plus y is equal to 86. And you don't have to use x plus y. You can use your initials or whatever letters you want. Now let's do the product. The product is the answer to a multiplication problem. So this means xy equals 1593. So we need to find two numbers that add up to 86 and multiply together to make 1593. To solve this one, because we have this xy term, I think substitution is the best thing to do. So I'm going to subtract y on both sides. So -y, -y. And when I do, I get I get x is equal to 86 minus y. So make sure you agree with me there. If I take this y and I move it over, it'll be 86 minus y. Now, x is equal to 86 minus y, so that means I can replace x with 86 minus y, because x is equal to 86 minus y. So this gives us 86 minus y, which we replaced for x, times y is equal to 1593. Okay? Now we can just solve this equation. So let's distribute. I'm going to come over here now. 86y minus y squared is equal to 1593. Make sure you agree with me. Y times 86 is 86y. Y times -y is -y squared. And I usually like to have my y squared terms be positive, so I'm going to move everything to the right-hand side. You could still use the quadratic formula if you moved everything to the left, but I don't know. I just like having my y squared be positive. So I'm going to add the y squared over. And that'll cancel, so that'll give me 86 y equals y squared plus 1593. And now I'm going to subtract 86y and move it over here. Okay, so that gives me an updated equation of 0 equals y squared minus 86y plus 1593. So essentially, I went to this. You could do this in one step if you wanted. I went 86 minus y squared equals 1593. I moved the y squared over, which made it positive. I moved the 86y over, which made it negative. If you're better at factoring than I am, you might see if this factors or not. I'm not sure because 1593 is a big number, so I'm going to use the quadratic formula. As a reminder, that's, in this case, y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So hopefully you have that memorized. So here we go. Negative b, which itself is negative, plus or minus the square root of b squared minus 4ac all over 2a is equal to y, because y is our variable here. Okay, so let's simplify that a bit. That'll be 86 plus or minus. Let's do 86 times 86 is, I'm going to write above here, 7396 minus 4 times 1593 is 6372. Be careful with your signs there. Sometimes you have a lot of negative signs. So let's do 7396 minus 6372. You get 1024. So 1024 is the number inside the square root now after you do this minus this. So let's go ahead and take the square root of that number. Oh, it could have factored. You get 32. So it's positive 86 plus or minus 32 divided by 2. Okie dokie, so let's do that. Let's do 86 plus 32 is 118. And if we do 86 minus 32, we get 54. So I have 118 over 2. I just added them, 118 over 2, and then I subtracted them, 54 over 2. So those are two different answers. So 118 divided by 2 is 59. And 54 divided by 2, I believe, is 27. There you go, 59 and 27. So now let's work backwards to find our x variable. So you'll notice that x plus y equals 86. So if I plug in 59 for y, I would just end up subtracting it over. So it's basically 59 plus what number is 86. So let's do 86 minus 59. And you get x equals 27. So the first point is 2759. And again, if you're wondering, and remember, don't confuse the y values. That's an x value for when we plugged 59 there. So we get 59. When we plug in 59 for y, we get 27 for x, because those add up to 86. Now what happens if I plug in a 27 for y? Well, I'm going to get x plus 27 equals 86. And I have a feeling what we're going to get if we subtract. So 86 minus 27 is 59. So what that tells you is the two solutions are 2759 and 5927. So we technically get two different solutions. If you were graphing these two on a graph, they would intersect at 2 points. But because of the way the question is asked, find two numbers whose sum is 86 and product is 1593, I think it's safe to say that those two numbers are just 27 and 59. All right, we're just hitting up against 10 minutes, so let's solve this final problem in part 3. Remember, if you enjoyed this, please make sure to like and subscribe. And if you have any questions, please make sure you leave those in the comments below. See you in part 3.